Hi everybody, good morning. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. We are discussing the lecture series video for the course Measurements and Instrumentation. Now we are in the Unit 1, that is the Fundamentals of Measurement Systems. We are discussing about the various characteristics of the measurement in the previous class. They are classified in the range of the static characteristics of measurement systems. Today, in this video, we are going to discuss about the dynamic characteristics of the measurement systems. What are the various dynamic characteristics of the measurement system? Come, let's get into the video. Let's recall a small topic of the previous class. The static characteristics of the dynamic system of the measurement systems involves the accuracy, precision, linearity, sensitivity, hysteresis, dead zone, threshold, and the loading effect. These are all the various characteristics that we have studied during the operation of the static characteristics. What are the dynamic characteristics? Why we need the dynamic characteristics? Dynamic characteristics are required to understand the instrument response to time-varying inputs. They are also used to minimize the measurement errors during transient conditions. The dynamic characteristics explains how a measuring system responds when the input changes with respect to time. Whatever there is a change in the input, based on the time, there is a change in the output. To minimize the measurement errors, studying the dynamic characteristics helps in identifying and reducing the errors like lag, overshoot, and time delay, ensuring accurate measurement of dynamic signals. A small introduction has been over here. What are the criteria for instrument measuring rapidly varying quantities over the time? What is the difference between a static and the dynamic characteristics is also mentioned, which is the slowly varying constant or a constant value is called as a static. Dynamic, as we all know, changes rapidly with respect to time. Dynamic behavior causes inductance, mass, capacitance, and the thermal capacitance. Various types of inputs are the step input, linear input, and the sinusoidal input. Dynamic behavior studied under both transient and steady state conditions. Speed of response. Here, this defines how fast or how speed the system is. The speed of response is the rapidity with which the instrument responds to the change in the measured quantity. Response time is the time taken to settle to a final steady state value. From this value to this value of y of plus infinity, what is the time taken? That is the response time. Input step response time taken to settle is 90 to 99%. The delay in instrument response changes to the measured system. Retardation time response begins immediately after the change occurs. Time delay response begins after the dead zone. Lag becomes critical in high-speed measurements. The ability to produce or reproduce output in same form as input is called fidelity. Fidelity indicates the changes without the dynamic error. 100% fidelity example is the linear input and the linear output. Whatever change in the input responds to the change in the output. This excludes the time lag and the phase difference. High fidelity and low fidelity difference is shown over here. What are dynamic errors? The difference between the true value changing with respect to time and the indicated value with no static error is called as a dynamic error. Overshoot due to the inertia of the moving parts. Pointer goes beyond steady state before settling. The damping ratio is less than 1, we call it as underdamped. If it is equal to 1, we call it as critically damped. And if it is greater than, we call it as the overdamped. Thermocouplers. An excellent example is the first order temperature sensor. The time taken to reach is 63.2% of its final value. You could see the image of a thermocouple as shown in the figure. The complete experimental setup of a thermocouple sensor, where we have a hot junction, a cold junction, two types of wires are used, and a copper lead wire is used to show the millivolt pointer. The various factors which are involved during this measurement are structural dimensions, material properties, fabrication process, and calibration environment. Where this is applied in aerospace engine combustion chambers, hypersonic vehicles, high energy weapon systems. Let's come and summarize. So we have discussed about the various dynamic characteristics of the measurement system in this video. The previous video, we discussed about the various static characteristics. So what are the various dynamic characteristics? So the various dynamic characteristics are the speed of response, fidelity, lag, and dynamic error. With this, we come into the conclusion. The key characteristics are the speed of response, fidelity, overshoot, measurement lag, and the dynamic error. Here we have listed the various references for this video. Thank you for watching the video. Let's join or meet the next topic. Thank you.